So welcome to 2020 question B1. This is a development and envelopments question. So we've got the image on the right shows the case for holding reading glasses. The shape is based on an equilateral triangular prism of side 75 now. Okay, so that's an important bit of information. Figure B1, so here's our figure B1, shows the elevation and plan and end view of that case. And we can see it's an equilateral triangle down here with a 60-degree angle. A pictorial view showing the surfaces of the case unfolded on the horizontal plane is also given. So here's it unfolded, and we've got additional dimensions here which possibly might be used, I suppose, for our orthographic views. So draw the given end view, plan and elevation. So reading questions is very important because it actually gives you a guide as to the order. So typically we're used to seeing elevation, end view and plan, or elevation, plan, end view. They're guiding us here, saying start with the end view. Okay, so we're going to be starting over there with the end view and before projecting to our plan and elevation. Our XY line here. Just come over enough space so it's 150. Okay, leave a bit of space between the views, and then 75. So just make sure I've got more than 150 there. So start approximately here. So our base is 75, and it's an equilateral triangle, so up at 60 degrees. 60 degrees here. Okay, and they're giving us some measurements here. So height of 12 for that straight edge or horizontal edge. So come up 12. Actually project that over because I'll use that later. And then we've got this edge 12 as well, and we've got 90 degrees symbol there, so that's telling us that this is actually at 30 degrees. Okay, so I need to draw a line here at 30 degrees, measure along that line, measure 12. I can project that back down at 60. So that's my outline of my end elevation or end view. Okay. Now, like I said, they did suggest the plan next. So we've got the end view, then plan. So let's project down to the plan 45 degrees. And you can start that kind of anywhere, just come over. So that's going to be my first edge. Project down these edges. Going across, we know it's going to be 150 is the length there given to us above the elevation, so 150. So at this point, just redrawing what's been given to us in the question. Nothing too complicated there. Okay, now I've got all my surfaces done, but then we've got this bit that folds over in plan, and I don't have any measurements given to me here. No measurements given in elevation, in relation to that height or that height, and no measurements given here. So if I look at my development, we have these measurements relating to it. Okay, I cannot use that measurement 20 and 25 here. One, because it's obviously not going to fit in, and two, this is a sloping surface, it's sloping away. So if I go back up here to my end elevation, that is an edge view of this bit that folds down. Lid, I suppose, or a seal, maybe there's a magnetic seal there. So I can take true lengths or true measurements along that edge. Okay, so I'll come here, it's going to be 20 to that first edge. I'll be measuring down 20 here, and that should align with that. I'll be measuring 25 then down further, and that should align with that. Okay, so and 25, I'll project those down to my plan view. So that's going to tell us the importance of following the question again and drawing the plan, or drawing the end view first. Okay, now I've got some measurements here, 55, 40 and 55. 40. That will allow me to draw back there. There. And there. Okay, now let's project all those lengths up. I shouldn't have any issue in drawing my elevation. So just redrawing what's been given to us. Detail that. Okay, we have those heights located in my elevation for that sloping surface. So across. Okay, so that's everything in my elevation plan and end view. Alright, so I'll take that off. A sticker or ST which appears as an equilateral triangle in plan, so this is an equilateral triangle again, or ST. It is applied across the three surfaces A, B, C of the case. So we've got A, B and C here of the case. So it's, when we look down on top of it, we're seeing this triangle or equilateral triangle that's going to be projected down onto those surfaces, so it's actually going to be longer in reality because these are all sloping surfaces. Okay, so I suppose the length of the base of the equilateral triangle there is 40, okay, in line with that, and the position of it, T and S, is in line with what we've already found, and then we just need to draw our equilateral triangle. So 60 degrees, 60 degrees here, That's my triangle or ST. Okay, so the position of those will be vertically aligned there in elevation, but we don't know the position of it, so we need to project. So work in reverse of what we did before, project back, so we have an edge view, project it onto the edge view and across. So, R, that's the position of R in elevation, or in end elevation, and there is R in my elevation. So S and T, there they are. Plot up. So S2, comma S. Sorry, made a mistake there, so T, scrap that out. So we can be located at S and T. So now it's about finding where it falls, so we've got this edge is corresponding edge, so we've got these 2 points on that edge. We'll go across, so we just need to extend them up onto corresponding edge in elevation. Those are 2 more points. Okay, folding down, we're going on to the next edge here. So that's our corresponding edge there. Point view of the edge here. So project up, and we've got the hidden detail line in elevation representing that edge. Okay, now you can just make these lines slightly just to show. So there are 2 more points. Okay, so we're going to have a bit of hidden detail in this. So we think at the front side, okay, we're seeing T. Okay, so they're going to be heavy lines. As we said, they projected to these 2 points then, so we follow it up. If you want to label them, 1, 2, 3, 4, you can. But I can follow that handy enough. Okay, then it's folding down over the opposite side, so this is going to be hidden detail now for the next few points. And finally, down to R, so hidden detail again, with R is on the opposite side. Okay, so that is a sticker. Right, so we're seeing an edge view of the sticker all the way around, and we have the projections of it. Okay. And finally, on a separate diagram, draw a one-piece surface development of the case. Include the outline and location of this RS sticker. Okay, RST sticker. So, I mean, in this, in the graphic, they've shown us kind of what it's going to look like. So it's giving us a good hint as to what we need to do. We just need to go and reproduce that using the true shapes or true lengths we can obtain from our elevation plan and end view, in particular our end view. So let's see will everything fit in this page. Should do. Okay, so I'm going to use. We don't have to, but I'm just going to project across this length of 7.5 and start with the base with the object resting on the horizontal plane, so this surface here. Okay. So I need the height of this is approximately 60, so it's going to be 60 on either side, so 60 representing that, and that when they're folded out, and 150. So I need a space of 150 plus 60, 60 and 170. Yeah. So if I start approximately there, 160. Okay, so the base of 150. Okay, and that's all going to be dashed lines indicating that they're fold lines. Okay, then we'll fold out the two sides, so it's essentially this view, or this shape we're trying to fold out. We know it was based on a equilateral triangle. Yeah, so we'll go 60 degrees from either side, which is 30 degrees in this view. Same on this side. Okay, and I can actually project straight out, because I've used my plan, I can actually project out these cut bits. No, they won't be at 60. Sorry, there's going to be a straight edge up here and then 60 degrees, so my apologies there. I need to measure up 12. Because of that flat edge that's been cut off. Okay, so I'll continue that on there. Like so. So hopefully that was in with my light line, so I can still fix it. Okay, so straight edges, heavy edges. Okay, and I can project, as I said, these out. That's going to give me my line here, which is at 60 degrees. So that's one side, and the opposite side. All the time as I'm doing this, I'm checking the solution that they've given to make sure, it looks the same. It's a nice kind of hint that they've given us, or extra information that they wouldn't necessarily have to give us. So, that's my two sides folded out and my base. So the width of 150 I can extend up and down. I can use that. Solve this. So start with the bottom. So this length here, okay, corresponds to here. Okay, so because if you can imagine, right, this is folding up, and it's matching up with this edge when it comes up, so those edges are the same length. Okay, so I can get that distance on my compass either from my plan or from my end elevation, or I can rotate it from my development that I've already begun. Okay, but it's the same length. So just to show their length, I can show those rotation lines. That's another surface complete. Just ticking them off one by one. Okay, and now we're going to be using these edges to solve the rest of it. So I know that represents that flat bit that we've cut off. So if you want to do the same thing, we'll rotate that back, you can, or you can take the measurement from here. Like this is our base, and we're literally just going to be moving as we go along, moving up along each one of those to solve the development. Okay, you can see it's the same length on both sides. It's 12. If you just want to measure 12, that works too. Just going to draw everything in light, and I can do my hidden detail or my fold lines then after. So now I'm on set. Gone from there, folding up around the back here. Right, you could also take that measurement from here as well, corresponding length. Another, and we're up onto this next one. Or if you take it from here, instead, just following it all the way around. Those wraps. Okay, and now we're on to this bit. So we've got our B, sorry, that's our C, that's our B. So now we're on to A. They've given us the measurements 20 and 25, which we could use, or just, I suppose, to keep consistent. I'm going to take my measurements here, folding down to T and S, which are in line with that lip. Okay, and 25, which is in line with, that's it there. Okay, so it's going to be contained within that. Some measurements then we can take is our 50 and our 40. So, I'm sorry, 55 and 40. So 55, 40 again. So I'll go around the outside of my object to serve my development. Putting my hidden detail there. So hidden detail there. You can even follow the hidden detail, or not hidden detail, fold lines that have been given to us. Dash lines. Okay, so that's my surface development, but we're not finished yet. They're also asking us to find a sticker RST. Okay, so it's back to what we had been doing before. We're going to use our orthographic views to solve this. Alright, so I'm going to start off with, let's see, start off with the T and S. So T and S there, they're folding down, so they were actually in line with our edges, or our corners there. So let's just extend them down, extend them down, and they were in line with that edge running along. So this is actually going to be my T and my S folded out. So T and S. Okay, and the quickest way to do this would be, right, I've got a center line here. I'm going to find the center line. It's going to be 75 to center. Right, so I'm going to use that to obtain measurements this way. So we've got T and S completed, then we're moving down and we need to find on this edge, which is this edge here, that distance is going to be the distance out to those points. So distance, so we are off that center line that I've established. Okay, then we're going down to the next edge, which is this fold line. So the next 2 points. Okay, and finally we've got R. Now R isn't on any specific edge, okay, or dashed line. So we need to find the measurement. So if we're thinking T and S, which there, which is this edge, and to there, which is this edge, and then we need that straight, that true length line, true length between this edge and R. So get that distance on my compass. Swing that. Bring it across to the center. And R, as we know, is in the center, so that's my R. Okay, so let's roll all these out. Show these straight lines. Okay, so that is the sticker included. Okay, so that's the projections of the development and the orthographic views. As you can see, a nice one there, and a great thing, like I said, always do the question in the order they give us. It'll just make life far, far easier for us.